When most people hear the word atom, they imagine something solid, dependable, almost guaranteed, as if atoms are the obvious building blocks of reality, like bricks in a wall that were always meant to be there. But this is where Richard Feynman would slow everyone down and gently pull the rug out from under that assumption. Because atoms are not obvious at all. In fact, from a purely logical point of view, atoms shouldn't exist. Their existence is not a necessity of reason, it's a fragile permission granted by the laws of nature. Think about it. Inside every atom are forces that, if left unchecked, would instantly destroy it. Positive charges pulling inward with enormous strength, negative charges that should fall straight into the center, energy so intense that collapse seems inevitable. Nothing about this setup screams stability. And yet here we are, sitting on chairs, holding phones, breathing air, all because these unstable arrangements somehow persist. Feynman's insight was not to treat this as normal, but as astonishing. The universe does not promise stability. There is no rule that says matter must hold together. The laws of physics don't guarantee atoms in the way arithmetic guarantees that 2 + 2 = 4. Instead, atoms exist because opposing tendencies reach a balance so precise that it feels almost miraculous. Attraction does not win. Repulsion does not win. Collapse does not win. Explosion does not win. Everything hovers in a narrow middle ground where survival is possible but never assured. This matters far beyond physics. Psychologically, we are addicted to the idea that existence is stable, that things are supposed to last. We assume the world owes us continuity. But Feynman's way of thinking cuts through that comfort. At the deepest level, reality is not built on certainty, it's built on tolerance. The universe tolerates atoms, it allows them. An allowance can be withdrawn if conditions change. There's something humbling in realizing that matter itself is provisional. Every object around you exists not because it must, but because it can. That distinction is subtle, but it changes how you see everything. Must implies inevitability. Can implies vulnerability. Atoms exist in a narrow window where the rules don't contradict each other too violently. Step outside that window and matter dissolves. Feynman loved pointing out that nature doesn't aim for elegance or permanence. It simply follows rules, and whatever survives those rules, survives. Stability is not a goal, it's an outcome. Atoms are not designed to endure. They just happen to endure under the current conditions of the universe. And that should make us uneasy in the best possible way. Because if the foundation of reality itself rests on balance rather than certainty, then permanence is an illusion we project, not a property the universe provides. This perspective invites a different relationship with existence. Instead of clinging to the idea that things should last, we begin to appreciate the miracle that they last at all. Instead of asking why things fall apart, we might ask why they ever held together. Feynman didn't offer this insight to make people despair. He offered it to sharpen their sense of wonder. When you realize that atoms are not guaranteed, every moment of solidity becomes extraordinary. The chair beneath you is not boring. Your body is not ordinary. They are ongoing victories against collapse, renewed every instant by a delicate balance of forces that don't care whether you exist or not. And that leads to a quiet but powerful motivation. If matter itself survives without certainty, then meaning is something we don't find. We create it in the narrow window we're given. The universe doesn't promise stability, but it offers possibility. What you do with that fragile permission is entirely up to you. After you accept that atoms are not guaranteed, the next unsettling idea naturally follows. Even when atoms do exist, they don't behave in ways our everyday intuition would ever predict. This is where Richard Feynman would usually pause, smile a little, and warn you that your common sense is about to fail, and that this is not a weakness, but a fact. Take the simplest question that seems almost childish. Why doesn't the electron fall straight into the nucleus? If you imagine a tiny negative charge orbiting a positive one, classical logic says it should spiral inward, lose energy, and collapse. End of atom. No chemistry, no biology, no universe worth talking about. And yet that doesn't happen. Not because nature found a clever workaround, but because our entire way of thinking about things breaks down at that scale. At the atomic level, particles are not little balls flying through space. They are described by probabilities, not positions. The electron is not somewhere waiting to be pinpointed. It exists as a spread-out pattern of possibility. Feynman emphasized this because people desperately want a picture they can hold on to. They want to imagine tiny planets circling tiny suns. But nature refuses to cooperate with that desire. Psychologically, this is deeply uncomfortable. Our brains evolved to deal with rocks, predators, and distances you can walk. We crave certainty here, there, now, later. Quantum behavior denies us that. It says, you don't get to know exactly, you only get likelihoods. And yet, out of this uncertainty comes stability. Atoms are stable because electrons are not localized in the way we expect them to be. This flips a powerful assumption on its head. We tend to believe that order comes from control, from precise positioning, from strict predictability. But at the deepest level of matter, order emerges from uncertainty. The atom holds together not because everything is tightly nailed down, but because nothing is. The electron doesn't fall in precisely because it cannot be confined to a single point without changing the energy of the system itself. Feynman loved pointing out that the universe is under no obligation to make sense to us. The rules are not designed for human comfort. They simply work. And what works, works spectacularly well. Every solid object you have ever touched depends on this strange refusal of particles to behave like objects. There's a philosophical weight to this that goes far beyond physics. We often demand clarity before we act. We want guarantees. We wait until things feel certain. But the atom itself survives without certainty. It exists in a constant blur of probabilities, and yet it forms the most reliable structures in the universe. That should make us question how often we confuse uncertainty with weakness. Maybe not knowing everything is not a flaw, but a condition for stability. Maybe rigidity is more dangerous than openness. In atoms, trying to pin things down too precisely destroys the system. In life, we often do the same, over-control, over-define, over-tighten, until motion stops. Feynman's deeper lesson here is not, accept mystery in a vague, poetic sense. It's sharper than that. It's an invitation to respect reality as it is, not as our intuition wishes it to be. The universe runs on rules that don't explain themselves in pictures, and yet they produce everything we value. Atoms endure, because nature allows uncertainty to do the work that certainty cannot. And if matter itself depends on that principle, perhaps the courage to move forward without complete understanding is not reckless, but fundamental. Once you get past the idea that atoms exist only because nature tolerates uncertainty, you run into an even stranger realization. Atoms don't just survive by chance, they are actively prevented from collapsing, by rules that have nothing to do with force in the way we usually understand it. This is where Richard Feynman would lean in and remind you that the universe is not held together by tiny pushes and pulls alone, but by constraints so deep they don't even look like forces. Consider what really keeps matter solid. When you press your hand against a table, it feels rigid, resistant, undeniable. Your intuition says this must be because atoms are like hard little beads packed tightly together. But that picture is completely wrong. Atoms are mostly empty space. If forces alone were responsible, your hand should pass right through the table like mist through fog. So why doesn't it? The answer is not that atoms push back harder, but that nature simply forbids certain arrangements from happening. Electrons are not allowed to pile into the same state. They cannot all sink to the lowest possible energy and sit there quietly. This is not because they're polite or repulsive or exerting pressure in a mechanical sense. It's because the universe says no. That configuration is not permitted. That kind of rule is deeply unsettling because it doesn't explain itself in everyday language. There is no visible mechanism, no hidden spring, just a boundary on reality itself. Feynman loved this point because it demolishes the idea that everything must have a simple visual cause. Some things happen or don't happen because the universe is structured that way. Psychologically, this challenges our obsession with reasons we can picture. We want stories with motion, collision, effort. But the stability of atoms comes from something more abstract, identity. Electrons are indistinguishable, and that indistinguishability has consequences. The universe does not let identical things stack endlessly. From that single restriction emerges the entire architecture of matter. This means solidity is not a property of stuff, it's a property of rules. The chair you're sitting on exists because nature enforces limits. Remove those limits, and matter would collapse into featureless density. No chemistry, no structure, no life. Order does not come from strength, it comes from restraint. That idea cuts much deeper than physics. In human terms, we often assume that progress comes from adding more effort, more pressure, more control. But atoms teach the opposite lesson. What makes them stable is not what they do, but what they cannot do. Their power lies in prohibition. Feynman would point out that this makes the universe profoundly economical. It doesn't need constant intervention. It sets a few rules and lets complexity explode. From one simple "you can't all be the same," we get elements, molecules, cells, brains asking questions about their own existence. And here's the unsettling philosophical twist. Matter is not held together by certainty or intention. It is held together by limits that no particle understands or negotiates. The atom does not know why it exists. It obeys, and existence follows. That should force us to reconsider how we think about freedom and structure in our own lives. We often resist boundaries, assuming they restrict creativity. But at the deepest level of reality, boundaries are what make creativity possible. Without limits, there is no form. Without form, there is nothing to build on. Feynman never asked us to be comfortable with this. He asked us to be honest about it. The universe is not intuitive. It does not reward comforting stories. It rewards accurate ones. And the accurate story is that atoms exist not because the universe is gentle, but because it is strict in very specific, invisible ways. Matter endures because reality refuses certain possibilities. And perhaps the same is true for any meaningful structure we hope to build. At this stage, once you accept that atoms exist because the universe enforces limits, rather than because matter is mechanically strong, you arrive at an even deeper and more uncomfortable idea. Atoms are not stable objects in the way we imagine objects to be. They are dynamic compromises, ongoing negotiations between competing tendencies that never truly resolve. This is where Richard Feynman would slow down, smile slightly, and warn you that if you're looking for a final, solid explanation, you won't find one. Think about what an atom actually is. The nucleus pulls electrons inward with enormous electrical attraction. Classically, those electrons should spiral in, radiate energy, and crash into the nucleus in a fraction of a second. If the universe followed common sense, atoms would never last long enough to form a sentence, let alone a civilization. And yet, here they are, persisting not because the forces are weak, but because something deeper intervenes. That intervention is not a physical barrier. There is no wall stopping the electron from falling in. Instead, nature imposes a rule on what motion is allowed. The electron cannot simply choose any orbit or energy it likes. Only certain states are permitted, and the lowest of those states is not zero. That leftover energy is not optional. It cannot be drained away. The atom is stuck being an atom. This is profoundly unsettling because it means stability is not a resting state. It's a tension that never relaxes. Atoms are not calm. They are constrained. They survive because they are prevented from reaching what intuition would call a more reasonable outcome. Psychologically, this runs against how we think about safety and permanence. We imagine stability as stillness. But at the atomic level, stability comes from constant motion within strict boundaries. Everything is vibrating, fluctuating, restless, and yet enduring. The universe doesn't freeze things into place. It traps them in patterns. Feynman loved emphasizing that this isn't just a technical detail. It's a lesson about how reality works at every scale. You don't get lasting structures by eliminating conflict. You get them by balancing incompatible demands under unbreakable rules. Attraction alone would destroy atoms. Freedom alone would dissolve them. What keeps matter alive is the impossibility of either extreme. There's a philosophical punch hiding here. Atoms do not exist because the universe wants them to. There is no plan, no goal, no intention toward matter or life. Atoms exist because, given the rules, there is no alternative. Once the laws are set, atoms are inevitable. Meaning emerges not from purpose but from constraint. This forces us to confront a humbling idea. Existence is not guaranteed by importance. We are here because the rules cornered reality into producing us, not because we were needed, but because we were allowed, and, in a sense, unavoidable. And if that feels cold, it's also liberating. It means the universe is not fragile. It doesn't rely on delicate adjustments at every moment. It relies on deep principles that lock possibilities into place. Once those principles exist, complexity follows naturally, relentlessly. Feynman would often remind his audience that understanding this doesn't drain the universe of wonder. It multiplies it. The fact that atoms are possible at all is astonishing, not because they are simple, but because they are precarious and still persist. Reality is not sturdy, it's precise. The deeper lesson is this: endurance does not come from eliminating pressure, uncertainty, or contradiction. It comes from learning how to exist within them. Atoms survive because they cannot escape the rules, and neither can we escape the structures that shape meaningful thought, discipline, and growth. So if there is something to carry forward from this, it's this simple, unsettling truth. Stability is not the absence of tension, it is tension held in balance. And once you see that, you stop searching for a perfectly comfortable universe and start learning how to stand intelligently inside the one that actually exists. Once you really absorb that atoms exist not because they are solid things, but because of rules that forbid collapse, the next realization follows almost against your will. Everything you call real is built on patterns, not substance. This is the part Richard Feynman loved to emphasize, because it offends our instincts in the most productive way possible. We like to imagine atoms as tiny balls, little hard pieces of reality stacked together to make tables, trees, and people. But that picture is completely wrong. Atoms are mostly empty space, and even the parts we think of as particles are better described as behaviors. An electron isn't a thing in the everyday sense. It's a set of rules about how something can interact, where it can be detected, and what it is forbidden from doing. The atom exists because those rules hang together consistently. What you're really looking at, then, is not matter but structure. Reality is not built from stuff, it's built from relationships. The electron relates to the nucleus. Energy relates to allowed states. Forces relate to probabilities. And out of those relationships, something appears that feels solid enough to sit on, to touch, to trust. This is psychologically disturbing because we want a foundation that feels concrete. We want a final layer where we can say, this is what it really is. Feynman's point, though he rarely said it in such heavy language, was that there is no such layer. Every time physics digs deeper, it finds rules, symmetries, constraints, and interactions, not essence. Atoms exist because certain patterns are stable. Molecules exist because larger patterns can form on top of those. Life exists because chemistry allows even more elaborate patterns to persist temporarily. Meaning itself, thoughts, memories, identity, is yet another pattern, built on the astonishing fact that atoms can hold arrangements long enough to matter. This reframes existence in a profound way. Nothing is permanent because permanence was never the point. What exists because it can last long enough to interact. Duration, not solidity, is the real currency of reality. Feynman often stressed that this doesn't make the universe less real, it makes it more subtle. A melody isn't less real because it's a pattern of vibrations rather than a physical object you can hold. In fact, its reality depends entirely on that pattern holding together over time. Atoms are like that. You don't have an atom, you witness a rule playing out consistently. And this is where the philosophy quietly turns inward. If atoms are patterns, then so are you. Your body is a temporary arrangement of atomic behaviors. Your thoughts are patterns of electrical and chemical activity riding on top of atomic rules. Even your sense of self is not a thing, it's a continuity. That might sound destabilizing, but it's actually clarifying. It means you don't need to be permanent to be meaningful. You don't need absolute certainty to be real. You only need coherence, enough structure to act, to learn, to leave traces. Atoms don't ask whether they will last forever. They exist fully within the limits of what's allowed, and in doing so, they make everything else possible. So here's the quiet challenge hidden inside this idea. Stop looking for unshakable foundations and start paying attention to the patterns you're sustaining. Your habits, your thinking, your work, these are your atoms. They don't need to be perfect. They need to be stable enough to build on. Because in a universe where even matter is a temporary agreement between rules, the most powerful thing you can do is choose which patterns you reinforce and which ones you let collapse when. When you follow this idea all the way to its end, you arrive at what may be the most unsettling discovery of all. Atoms do not exist because the universe prefers complexity, beauty, or life. They exist because once the rules are written, reality has no choice. This is the conclusion Richard Feynman kept circling back to, not as a comfort, but as a challenge to how we think about meaning itself. We like stories where existence has a reason. We want atoms to exist so that stars can form, so that chemistry can happen, so that eventually someone can stand here and ask why atoms exist in the first place. But physics is brutally indifferent to that key. ND of narrative. The universe does not work backward from outcomes. It works forward from constraints. Once you accept the basic laws, quantization, uncertainty, forces that behave the way they do, atoms are not optional. They are unavoidable. The universe isn't aiming for matter. Matter is simply what happens when the rules corner reality into certain behaviors. No intention, no foresight, just inevitability. That idea hits hard because it strips away the comforting notion that we are here for a cosmic purpose. But Feynman's genius was recognizing that this doesn't make existence empty. It makes it honest. Meaning doesn't come pre-installed in the universe. It emerges locally, temporarily, inside the structures that the rules allow. Atoms don't exist for anything. Yet because they exist, everything else becomes possible. Stars burn, planets form, life organizes itself, minds appear that can reflect on their own improbability, not because the universe wanted them, but because nothing stopped them. There's a psychological parallel here that's impossible to ignore. Many people wait for permission to exist fully, for certainty, validation, or a guarantee that their effort will matter. But atoms never ask whether they will be worth it. They don't hesitate because they might decay someday. They exist because the rules allow them to exist now. Feynman often emphasized that physics teaches humility. The universe doesn't owe us explanations that feel emotionally satisfying, but it does offer something better, clarity. Once you see that atoms exist because they must, you stop asking whether reality approves of you and start asking what reality permits you to do. This shifts responsibility inward. If meaning is not written into the fabric of the universe, then it becomes something you construct through patterns of action, thought, and care that persist long enough to matter. Just like atoms. And here's the final twist. Inevitability does not kill wonder. It sharpens it. The fact that atoms are unavoidable does not make them boring. It makes them miraculous in a deeper way. From a small set of cold, abstract rules emerges everything warm, vivid, and fragile you've ever known. You are not standing on solid ground made of tiny bricks. You are standing on a delicate balance of rules that just barely allow you to stand at all, and that should not make you passive. It should make you precise. Because once you understand that existence itself is a narrow path carved by constraints, you realize how rare and valuable every stable pattern becomes. Every idea held together, every relationship maintained, every moment that doesn't immediately fall apart. Atoms do not last forever, neither do we, but lasting forever was never the requirement. Lasting long enough to make a difference, that's the real miracle. So take this with you. The universe didn't promise you meaning, stability, or permanence. It gave you rules, and just enough room inside them to build something that matters. What you choose to build and how carefully you hold it together is entirely up to you.